Hello, guys. Sorry for the inactivity these days. Let's discuss Leetcode contest problems of December 1st today. So, this is the first problem smallest number with all set bits. Here in this question, you are given a positive number n. Return the smallest number x greater than or equal to n, such that the binary representation of x contains only set bits. A set bit refers to a bit and binary representation of a number that has a value of 1. Here is an example. Okay, so let's see the constraints. Manageable. Okay, so now let's discuss this problem in detail. We are given an integer positive number n. We have to find the smallest number greater than n that has all of its bits set. Suppose n equals to 6. We have to find smallest x greater than 6 with all of its bits set. We have to start from x equals to n because as it is, we have to find out nx which is greater than n. So one brute force approach would be we can just start from n and carry on till we find an x which is greater than n and is smallest. As we have been given a positive number n, so we would increment x by 1 every time we don't find its binary representation to be satisfying the condition given to us. That would be a brute force approach. So, but it would not satisfy our constraints as it would be an exponential solution because checking for these many numbers, it can also take infinite time. So let's find an efficient approach. Let's find out some pattern. So we would start from x equals to n, which is 6 here. I'm just representing it in binary form as 110. Here all bits are not set. So increment by 1. This was our. So now the x becomes this, which is 1117, which can also be written as 2q minus 1. And it has 3 bits set. So we can see a pattern. 2 raised to a minus 1 would give me a set bits. A set bits. Let's try it out with 4. 2 raised to 4 minus 1 equals to 15. This would be written as 1111. So this is the pattern we have to find out. Now this would reduce our solution time complexity to log of n plus 1. Let's write out this code now. Why is it not? So, and start from a equals to 1. While true, this is an infinite loop. Base I'm left shifting 1 by a minus 1. This would be equivalent to 2 raised to a minus 1. So if my base is greater than n, and I would return base. If not, I would just increment a by 1. So this would do. Let's check if it's passing all the given test cases. It is. Okay, so let's jump into the second question now. Identify the largest outlier in an array. You are given an integer array names. This array contains n elements, where exactly n minus 2 elements are special numbers. One of the remaining 2 elements is the sum of these special numbers, and the other is an outlier. So n minus 2 special numbers, and remaining 2 elements, out of which one is the sum of the special number and other is outlier. Outlier is defined as a number that is neither one of the original special numbers nor the element present in the sum of those. We're also given a note that special number, sum element, outlier have distinct indices, but may have the same value. Return the largest potential outlier in numbers. So we have to return the largest outlier that can be possible, satisfying the conditions that there are n minus 2 special numbers, a special sum numbers representing the sum of the special n minus 2 numbers, and the outlier. So these are the examples. Sum of these two would be 5. This is the sum number, this is the largest outlier. These are the constraints. Thus, given that the input is generated such that at least one potential outlier exists in numbers, it's not possible for it to not exist. Let's understand the question to towards the solution. So here n minus 2 special numbers, some number, outlier, and size array. We have to assume that it's then an outlier is present for all test cases. Outlier can have the same value as of n minus 2 special numbers or some number at distinct index. We have to find the largest outlier. So one brute force approach we could think of is creating all subsets of n minus 2 size using loops. This would require n square order of operation. Then we have to calculate the sum of this. So that would be an O cube time complexity. Now we have to compare and generate the largest outlier out of the remaining elements every time. This would be approximately O n cube time complexity, which is not at all feasible for our 10 cube into 3. This will not satisfy our constraints. So we would think of a better approach than just the plain finding our approach. We could use the prefix sum method to reduce this n cube to n square, but still comparing and generating would require us to iterate once more. It would be the same n cube. So let's reduce calculation time using additional data structure and using a dictionary here. same as hash maps in other languages uh, except Python. So this is my 1D array. These are the n minus 2 special numbers. One would be a sum and one would be an outlier, always. It's given in the question that one outlier is always present. We have to find the maximum outlier. So I would try run with this example. Using counter in Python, I would generate this dictionary of count of every element present in the nums array. Nums array. Now iterating over this array, element by element. First would be I equals to 0, nums equals to 1. I would calculate the total sum, which would be 10 here of the whole array. And I would store minus 1001 as my initial max value of uh, the largest outline. Largest outline. So for 1, I would decrement the count of 1. First of all, visit of 1 minus equals to 1. It would become 0. Then result would be total minus 2 into sum. So num. This would be 8 here. This would be 8 here. And then if visit of this result, which is 8, is present in the dictionary which is not here, I would update the answer with max of answer and this result. And afterwards, I would return answer, whatever it is. Here in this case, answer would be 4. I didn't find it in the first one, so I would go with the I equals to 1. Total will remain same. Answer also is minus 1000 right now. Now I would decrement visit of 2 by minus. And I would not forget to restore this before calculating, because in the next iteration, then it would cause a problem if I don't restore this to its original value. So for 2, I would go on like this. 10 minus 4, which would be 6 here. I would find out if there is a 6. No, there is not a 6. I would iterate to the third one. 10 minus 6 is 4. I found out 4 in. So I would update the answer to 4. Now the answer has become 4. Now Last num, total 10 minus 8, 2. 2 is also present, but I would update it with 4 only because 2 and comparing 2 and 4, 4 would be greater than 2. So my answer would be 4. This was the dry run. Let's write out the code for this now. Total equals to sum of nums with the dictionary of counter nums is equals to for num in nums. I will iterate over the whole array. I would decrement the value of num by 1. Calculate the result now using this formula. Would be num. If visit of this result is present in the counter dictionary, I would update the answer with the answer and result comparison. Would restore the num count before going to the next iteration, then return the answer. Let's see whether the solution is correct or not. Okay, it is getting accepted. Now to check all the hidden test cases. Yeah, it is running quite well. So let's meet in the part 2 of this discussion where I would discuss the other two problems of this lead code challenge. Bye bye. Please like and subscribe for more such videos.